Hi guys, Gerusek here and welcome back to the channel. So in this video we will find out which moving average is the best one for prediction of the future prices. What we will basically do is that we will take a moving average and we will calculate how precisely it can predict the future price development. I will demonstrate this on my chart right now. So as you can see, I have added this 200 moving average to my chart, and I have also added these two rectangles. Each of these rectangles equals to 60 candlesticks on a chart, so the size of the rectangles is the same, but as you can see, the first rectangle only focuses on the moving average and the second one focuses on the price. So I should actually change this like this. So what I will be doing is that I will firstly analyze the development of the moving average, and then I will calculate the correlation of future prices. So I will calculate the correlation between the moving average and the future prices. And if the correlation is positive and is higher than a certain level, we can say that there is a linear relationship between the previous moving average and future prices, which also means that there is some predictability. We will perform this test on multiple periods, so we will test, for example, 50 moving average, 200 moving average, 100 period moving average, and we will compare all of these periods to find the best one. So I hope this video will be interesting. I surely think it will be interesting because, it's something new. Okay, so now I think we can start with the coding part of this video. So I will open my MT5 editor and I will create a new indicator. So I will open my YouTube folder, click on new file, and let's check the custom indicator here. Click on next, and let's call this best moving average test. We will need to add some parameters, but now I'm thinking about adding them inside the actual code, and I think I will add them later on. So let's just click on next, and let's add one plot. Or do we need any plot? Let's add one plot just so we can plot out the moving average that we will be performing the analysis on. And we can change the color to, for example, orange red, and I think we can click on finish. Okay, so this is what we are working with so far, or right now. Okay, so let's add the inputs. We will need two inputs. So the first input will be of type integer, and it will be input moving or testing period, okay? This will be the second input. So the first input will be moving average period. And let's set the initial value to, for example, 50. Okay, so this input basically means which period of the moving average we will be testing. And the second input that we have to add is basically the size of this testing window. So right now we are analyzing 60 bars basically, but we can also be analyzing, for example, 15 bars or so. And this will heavily influence the correlation and therefore the predictability. Because I think it's safe to say that the moving average will be more precise on the prediction to nearer future, basically. So for example, if you want to predict future 15 candlesticks, the prediction will be more precise than if we were to predict, for example, for the future 200 candlesticks. So it will be very, very important parameter. Okay, so input integer, and let's call this input test window, and let's set the initial value to 25. Okay, so what we need to do now is that we need to add the handle for the moving average indicator. So there are basically two ways of how we can calculate the moving average. We can either use the built-in indicator for which we need the handle, or we can just calculate it inside the onCalculate function, simply sum the prices together and then divide it by the total number of prices. So I think I will choose the built-in indicator method for now. So let's do MA buffer, and we can move on to the onInit function. So right here, what I will do is that I will assign the indicator to the moving average buffer variable that we created. So MA buffer will be equal to IMA, and this will be symbol period current. Moving average period will be equal to input MA period. And then we have shift, which will be equal to 0. And now we can also specify the mode of the moving average. So we can choose from exponential, linear weighted, simple, and smoothed. Let's go with simple moving average, but of course, if you want to perform these tests on your own, you can choose your own mode as well. And then the price, so we can also choose from different prices, but I will go with the closing price because it's the price that we usually want to use. So click on compile. So far so good. Okay, so now on calculate function, I will create our main for loop. So static integer I will be equal to input, let's do maximum value here. So let's do input MA period and input test window. So we will set the initial value of I to the larger one out of these two variables, and then we can do our classic for loop. So for I lower than rates total and I plus plus, and here what we can do is that we can, or let's do this actually outside of the for loop. So let's create an array for the moving average values. So MA, or let's call this MA array. Okay. And right here, let's call the copy buffer function. So now what we will do is that we will, well, now we should stop for a while and just think about what we want to do right now. So we want to do two things basically. So the first thing is that we want to load moving average values. And the second thing, so let's just say that this is task number 1. And task number 2 is that we want to get prices or shifted prices. Okay, so these are the two things that we have to do right now. So what I should do is that I should also create an array for those prices. So prices, and let's continue. Okay, so now if you think about it, if our test window is equal to 25, for example, it means that we have to start at index 50 for moving average array, and at index 25 for the prices. So what we can actually do is that we will call the copy buffer function, and hopefully we will get this right, or I will get it right. So indicator handle is moving average buffer. Buffer number is 0, and now this will be very, very important. So let's do rates total minus I, which is the most important thing. And now we have to add So now what we want to do is that we want to do input test window. Okay, and now we want to load this number of moving average values, I guess, and double array, and we want to store these values inside the moving average array. Okay, so I hope this is right. So rates total minus I, this basically gives us the correct corresponding index for the current candlestick. Okay, and then we have to add the test window, so we shift basically the values by 25, and then we get the next 25 values, and we store all of these values inside the moving average array. So I think this does make sense. And now we want to do the same thing to get these prices. So we can use this copy close function. Okay, so it will be for the current symbol, current period, and now the starting position will be rates total minus I, but in this case we won't add the input test window variable right here because this is sufficient, and then count. We still want to work with the input test window number of values, so let's input it right here, and we want to store the results into prices. Okay, so now we should test whether this actually works. And what also I will do is that I will create just one more array. This will be called MA current. Okay, and just let me do this, please. So MA current, and then I will say that the main buffer position I is equal to MA current position 0. Okay, so if I compile this, what should happen is that we should see the simple moving average on our chart. So this is basically what this piece of code does. And after that, we will check whether the copy buffer, or whether we successfully loaded the correct data into moving average array and prices array. Okay, so let's check the moving average first. So let's go here. Let's open the indicators folder, YouTube folder, and its best moving average test right here. Okay, so if I add this, you can see that this is our moving average, which should be equal to 50 period moving average. So let me just check this. So if I change this to 50, it should correspond. Okay, so it does not correspond with, okay, it looks the same, but it's shifted, obviously. So yeah, sorry, this should be 0, because now you can see that this moving average is shifted by 25 values, or 25 bars. And now when I update this, I guess I have to remove this one and do this once again. Okay, so what's the problem here? Oh yeah, sorry, we want one value, not 25, and now they are the same. Yeah, so now you can only see the thick one, or if I zoom in, you can see that they are at the same price level basically. Yeah, so this is correct. So now we can move on to check whether we have correct data inside the moving average array and prices array. Okay, so just for the sake of this test, what I will do is that I will change the I variable to rates total minus 1, I guess, 2. Okay, so I'm just changing this I variable, so we run this one time. Okay, and then I want to print out the arrays. So array print MA array and also array print prices. Okay, and between these two prints I will print out something like this, so we can actually see the corresponding prints. Okay, so okay, so what do we have here? So let me just clear this so we can see what's happening. Okay. So okay, I think this doesn't work entirely correctly. You can see that this moving average acts very funny. So this is not correct, and the thing is that on every so this is not correct because I keep doing the same thing over and over again. Anyway, if I do this and we get to the end of these print statements, which will take a while, I guess, what we will see 6 5 this is approximately 6 5 5 something, so this should be correct right here, and this should be 6 5 4 4 5 4 6 4. Oh yeah, we go right here, I guess. Okay, so it seems like this is corresponding well as well. I will print out one more thing. So print array size of the MA array just to check its size, and then I will also print out the size of prices so we can make sure that both of these arrays are the same size, which they are. Okay, perfect. So we can actually continue. Okay, so now the next step will be very, very simple. I will calculate the correlation. So to make this process even more simple, I will include the statistics library, basically, that we can use with MQL5. And I can do it by including the math/stat/normal.mqh library. Okay, so this is it. Now I will create new double variable called correlation coefficient, which will equal to 0, and then I will call math correlation Pearson, which I think is the best one in this case to use. And in here I will insert the MA array as the first array, and the second array to input here will be the prices, and I will store the result into correlation coefficient variable right here. Okay, so this is good, I guess. So now I'm thinking about creating one more correlation array inside which I will basically store every correlation coefficient that we calculate. Okay, so let's do that. I will make this array dynamic. So first of all, I have to resize this array on every iteration. So correlation array, the new size will be equal to the current size of the correlation array plus 1, and the reserve size will be 0, and then I can assign its value. So array size correlation array minus 1 is equal to correlation coefficient. And at the end of this for loop, I can do print array, array print. Come on. And I want to print out the correlation array. Okay, so if I run this, okay, so why? Okay. Yeah, so it took a while, as you can see, because we have a lot of a lot of calculations right here, and we also array print a limit. Okay, so well, this is just like, okay, so we have a limit for the number of values we can store inside an array. So we cannot, you can see it here, we cannot store every correlation coefficient. But what we can do, like this was just for the visual part, basically to see that we are calculating the correlation coefficient. So what we can do instead is that I will just delete this part. We don't need an array. We also don't need this. What we do need is cumulative correlation coefficient, and with each iteration we will basically update this variable by the current correlation coefficient. And then we also have to keep track of number of iteration, so we can calculate the average value at the end. So iters plus equals 1, okay? And right here what we can do is that we can create a new double variable called average coefficient, which will be equal to cumulative correlation coefficient divided by the iters. And I will just change this to double format, so we are dividing double value by double value. And I think this should be enough. So then we can print average, correlation coefficient, and here we can just add the average coefficient. So this is how we can bypass using arrays average why is it none? So okay, so this is the process is correct, I guess. I just did some mistakes somewhere. So what I will do is that I will print the cumulative correlation coefficient first, so I can actually see the value that we are working with. Non-existing number. What is this? Okay, so this is pretty strange. Maybe there's a limit. Let me just try to change the data type. Okay, so this is 0. Okay, let's just print cumulative correlation coefficient right here. So now we will print this. Why? What the this is very strange. Okay, so let's just print correlation coefficient. Okay, so correlation coefficients do work correctly, but when I do this thing, it doesn't do anything. So, okay, this is pretty strange. I'm not sure why. I guess the numbers. Let's try this with some lower number of. Let's try this on the last 5,000 candlesticks. Okay, yeah. So I guess the issue is with the number of observations. The number of observations is too high, I guess. So if we run this on 5,000 candlesticks, so what I will also do is that I will create another input, and I will do input analysis on candles, which will be equal to 5,000 by default. Yeah, so I will replace this value by this one. So this works correctly. If I clear this and I change the time frame to 5 minutes, you can see why is it doing this 2 times? Yeah, okay. So here is the overall correlation, and this is the average correlation divided. Yeah, so if I change this to 15-minute time frame, now you can see that it updates correctly. So if I change this to 1 hour time frame, I'm not sure why this keeps popping up, but it doesn't matter. These are the correct values. Okay, so this is how we can calculate the correlation between previous or past moving average values and the future price development, basically. So now we can see that the correlation coefficient doesn't look that good, but that's something we can test as well. Okay, so we have some parameters that we can play with here. So the first one is moving average period. I guess that as we increase the value of moving average period, it becomes less volatile. Yeah, it basically has more steady development, and as we decrease the test window to, for example, 10 candlesticks, that should also increase the correlation. So let's test that, and it does it does make it a little bit better, but not by much. So now, like, okay, I have to figure out. So what I will do is, if I will just do this thing right here, just to avoid that second print statement. Okay, yeah, so now this is correct. Let me just clear this, and yeah, so this is correct. Okay, so now what we can see is that the correlation is negligible. Yeah, it's very near to 0, which basically means that there is no linear relationship between the previous moving average development and the price action that happens after that, basically. Which, of course, does change as we change the time frame, for example, and the settings for the moving average. Yeah, so we can, for example, try something like 5 candlesticks, and let's do 5 moving average. Okay, it doesn't seem to help. Okay, so this looks a little bit better. Oh, it does not. Okay, so now we have to find a way how to test this. Let me just check how long this video actually is. 30 minutes. Well, we haven't done that much so far, but I guess that's okay, because this is a good start. So now I'm thinking about making this code more dynamic and changing it in such a way that we can optimize, or we can test the correlation for multiple moving average periods automatically. Yeah. What can we see here? Let me try one more thing. Like, now we are comparing the moving average to the price. Yeah, so past moving average, future price. Let me test. Let's compare the previous moving average to the future moving average. So now what we will do is that we will replace the price values with moving average values. So we will be comparing, like, the results should be the same, because moving average is a derivative of price, basically. So the results should be the same or very similar. It shouldn't boost the performance that much, but let's just test this, I guess. So what I will do is that I will copy this line, I will comment out this line, set it here. So moving average buffer, this will be the same. I will delete this part and I will store this inside the prices, and this is the only thing I have to do. Yeah, I don't have to change anything else. Okay, so this does change a lot. So now you can see that our latest average correlation coefficient is 0.46, which is pretty strong. Yeah. If I change this to 15 minutes, it's also 46, 49, 50, 46, 45. So this is pretty significant. So what this basically tells us is that with these settings of 15, so moving average period is 15, test window is 5, is that we can predict the movement of 15-minute moving average 5 candles to the future with some amount of certainty. Yeah. So as the correlation coefficient goes higher, it means that the certainty is higher as well. Yeah. So which is pretty interesting. I guess if I change this to 200 and test window to, for example, let's leave it to 5, the correlation is 84%. Yeah. Which is also very, very interesting. So what this basically tells us is that, let me just delete the moving average. So this is the one that we are working with right now, and I can also make this a little bit bigger on the screen. Okay, so we have to redeploy the, which is okay. So 205, 5,000, we can leave it like this. So what this correlation of 0.89, which is very, very strong, basically tells us is that there is a very high chance. So if you, for example, look at this point in time, yeah, and we look at the past development, we can say that there is very high chance that for the future 5 bars, which is this window basically, the trend of the moving average will be the same as it was before, yeah, or as it was for the last 5 bars. Yeah, so for example, so there is a very high chance that you will see this trend development 5 candlesticks in the future. Yeah, so that's how you can basically interpret this data. As I increase the test window, the correlation should go down significantly because, oh, it's still pretty good. Yeah, so now I change this to 50, which is very, very significant. Significant distinction. Okay, so what this basically says, correlation of 0.63 is still very, very significant in this case. So if you look at the last 50 bars, which is this, yeah, and if you look at the development of the moving average, we can say that with this amount of certainty, or like it, you cannot convert correlation to percentage or probability, but it just tells you the strength of the relationship. Yeah, but you can say that this is pretty significant. So you can say something like, with a pretty high probability, the development of the next 50 bars will be dependent or will correlate with the development of the last 50 bars. Yeah, so that's very, very interesting. If I change this to 100, for example, the correlation goes down, but it's still pretty good. Like, the thing, I think this is caused by the moving average period, because 200, like, if you check the chart, you can see that the line is very, very steady. Yeah, there are no huge changes in the direction. Like, it follows the trend basically. So I think this is the reason why these tests look so good. If I change this to, for example, 15, so I introduce more volatility into the calculations, you can see that now the correlation is very, very small, meaning we cannot predict, for example, for 15-minute time, 15 bars candlestick, 15 period moving average, we cannot predict what will happen 100 candlesticks from now on. Yeah, which makes sense, like since there is much more volatility and the moving average is more responsive to the price fluctuations. Yeah, this makes sense. So yeah, like you can play with it. I wanted to make this more dynamic to find the ultimate best moving average period with the best test window, but I guess I will do this in another video because it's not that simple task to do. It requires some thinking, yeah, and since I haven't prepared this video at all, it was just an idea that I just got, it could take much more time. So I guess this will be for a second chapter, let's say, where we will test what is the ultimate moving average period with the test window to predict the future development. So yeah, this is it for this video. I hope you found it interesting to see what is possible with MQL5 and how easy it is, basically. Yeah, this script took a few minutes. Yeah, if I didn't have to talk and describe what I am doing, it would take me around, I don't know, 4 or 5 minutes. So it's very, very simple. And you can do it as well. So thank you for your time and for your attention. And yeah, I will see you in the next video. Bye.